Hello friends, we will lecture git install npc. Okay, so Google search is a git and click to the git. Okay. So this git local branching on the chip. So this website is open at https:/git-scm.com. Okay, so install the git, install program. Okay. About land, tools, reference, install, and community. This is a git setup. Okay. And install for window. Click to install for window. So, so click here to download. Click here to download. Latest version is at 2.54.0 x64 version of Git Windows. Okay. And macOS window. So this install the macOS. Linux window. This step by step the Linux window. Okay. Build for source. So window, click to where, click to where to the window. So install the window. Okay. So install the Git setup. Okay. Git software is installed. So this is about Git is fast. Git is widely used. Git has a huge ecosystem of tools, free and open source. Git is a free and open source. Like Pro Gitbo video. This video is available on Git, cheat sheet, and external link. This video are available. So what is version control? What is version control? This video is available in Git.
Hi, I'm Matthew McCullough with GitHub, and I'd like to take the opportunity today for those of you who are new to version control to describe at an abstract level what it does and how it relates to your job. Have the common behavior in place that we create things, author new files, write the content, we save them, we then subset it, and what the contents of that, at which point I can look at any adeptly buy a full-fledged version control system like that of Git. This idea of bringing these changes together, it's a good implementation of a version controls that compose a project. Graphics, designs, documents, and in many cases, even some form of programming code, adjacent files, and bring them together for working at the same time kind of idea. Lastly, Git is approachable. Double-click and right-click for navigation and changes through those versioned elements. This might bring to your job as a knowledge worker.
What is Git? This is Git.
Welcome to another screencast on Git. This is Matthew McCullough with GitHub, and I'd like to talk to you today about Git enabling your projects and how that goes above and beyond what we've discussed about the basics of version control in the first episode. When we're looking at Git, the big idea here is that we actually have an implementation of the idea that we were previously calling version control. Git is one specific flavor of this. There are many options out there today, but it's a very most. Many version control systems require a complicated server setup to be effective. On the other hand, Git is actually locally enabled, meaning that you can version control items already examined before, and that's one command line for someone that we'll call developer. You could even take turns at the keyboard, and the implementation in Git at the command line for someone that we'll call developer Dana would look something like this. It would start off with the initialization of a project, the setting up of the Git control structures. That's done at the command prompt with a simple git init and then the name of the project. That creates a directory, a folder that can contain the project files as well as the control files that store the historical elements, the history snapshots of your documents, images, source code if you're working with a program. Git add is the command that actually notices the files and puts them into a kind of holding zone, ready to permanently be committed. And then nicely aligning with the word that we just used, commit is the keyword that actually permanently records a historical version or snapshot of the files as they exist at a given point in time. That's a simple use of Git, but we want to take it to the next step when people are actually collaborating in a fashion when they're not at the same machine, when they're not working at the same time. And it actually gets quite a bit more complicated from the conceptual side, but hardly any more complicated from the implementation side of Git. Git is designed from the ground up for team collaboration. Every feature that you see is centered around making this experience simple, easy, being effective for even hundreds of developers. Having this at the core of our tool takes us back to that picture one more time. People working in sequential fashion. However, they really don't work in sequential fashion. It's this more complicated diagram. It's people working at almost different times, but with overlaps, and all wanting to bring back their work to the home base to have it incorporated in the primary copy of the project. While that's a wonderfully simple way to describe it, it doesn't really model reality. Reality is that people are working at different times, but with slight overlaps, each taking a personal copy of the files as they see them at a point in time, performing their own enhancements to them, but then bringing them back to the central copy and wanting to unify, the technical term is merge, those changes with the primary copy of the documents, the images, and the source code. It's this overlapping of time and almost parallel work that complicates a lot of matters. The implementation is significantly helped by Git. With an example that uses both Doug and Dana working on the same project at effectively parallel times, Doug can work on his master branch, an arm of the project, adding some new graphical work such as a logo, and then sending that to a central server, now adding that network component to the idea of version control, and then having Dana also participate, perhaps again at exactly the same time as the work that Doug is doing, with her contributing her feature work, perhaps some programming code, and then bringing that into the central server-based copy as well. But that last step is the critical one, bringing all the code into a unified set, merging together both Doug and Dana's work. That can be done with Git as simple as retrieving the copy of the centralized versioned files down to Doug's individual machine, and then executing a command that merges all of that work together. It'll provide help if there's any conflicting files. It'll walk you through the steps of deciding whether you want to keep Dana's or Doug's changes if they happen to collide. And in the case that they're working on similar but different files, it will merge them together completely automatically. The third category of person to speak about when discussing an implementation of Git is the person who will use it for a long time, find all the deep crevices and features of it, and in fact want to stretch it to its absolute maximum. That person is also served well by Git. Even though it's very easy for the introductory person, it's also very capable for the advanced individual. You can find that through its Unix-like structure, the ability to glue together these small programs and use option switches to control the behavior, that it suits the needs of an advanced version control user extremely well. Piece by piece adding of little segments of a document, and the committing of just some of those pieces that were selected, and then a historical graphical representation that can be done even from the command line, showing when people branched files, when they merged them back together, who did what when, on which date. All of these option switches, which at the moment for a beginner might seem intimidating, are actually extremely satisfying to the advanced user. Git serves both ends of the spectrum extremely well. Version control is a simple concept, but it's complicated by the work modes of today. People working in parallel, sometimes on the same files. Git serves that beginning user extremely well. It serves the merge capabilities well when more than one individual's work needs to be brought together. And it scales well to the advanced user over time, wanting to have precise control over the commit and over the visualization option switches. Thanks for listening to the concepts behind version control and now specifically applied to Git. I hope you'll join us for our next episode. Hello, I'm Matthew McCullough. Welcome to the third episode in the series of Git Basics. Today, I'd like to take advantage of showing you what it would take to install, set up, configure, and then make your very first use of Git from the command line. We'll do that by first talking about where you would acquire this and what platform it works on. Git actually has mature installers, package managers, distributions, and source files for all of the major platforms today: Linux, Windows, and Mac. That download can be acquired from gitscm.com, the official homepage for Git/downloads. It'll automatically detect your operating system and present you with the appropriate link. A quick click, download, and a few setup steps, and you'll have Git installed on your system. Next, you need to configure your username and email address. These are not used for credentials on any of the Git hosting sites. They're simply local records to give you credit for the work that you'll be doing in the version control system. These are configured by two simple instructions from the command line. First, we'll want to configure your username and email address with Git. These are not credentials used for any hosting service. They're merely who to give credit to when it records the historical events that we call commits. You'll first configure your username. In this case, we'll just make it a friendly name that you would go by for team members or more publicly known on the net. User.name is the key that we're setting. Dana DevOps is the value. Its corresponding cousin is user.email. And we'll set that to whatever we would like, again, to record in our commits and to be known by, either within the team or if we share this code open source publicly. That's all the configuration that's necessary. From there, we can advance to actually making our first use of Git. It's very straightforward. Let me show you. Heading to the terminal window once again for our instructions, we'll begin with a git init and the name of our project, which will create a directory of that last parameter that we're passing on the command line. In this case, project 1. We'll change directory, situating ourselves inside that project directory. We'll do a bit of coding. In this case, I'll keep it simple and call it just creating file1.txt. And then we'll decide to add that to version control. Adding, in this case, opts it in to the next action, which is a commit. The add is not yet permanent. It's simply signaling that we want the file to participate in the next commit. We'll conclude by making that permanent record, recording the state of the file at a given point in time, and we do that with the commit command. -m allows us to provide a commit message at the command line. What we'd like to describe happened in the activities that are being recorded for this file. That's it. You've now recorded a historical event in the Git version control system, and you can repeat the coding, work on a new file, work on an existing file, add it, even add more than one file, use a wildcard, and then repeat that commit at the very end. Just keep cycling through that, and you'll keep recording historical events that can be returned to at a later point in time. That's all there is to getting started with Git, but I imagine you'll have much more that you want to learn, and the place to go for that documentation, tutorials, videos, and all the user reference pages is at gitscm.com/documentation. 2 simple configuration entries, and away you go, creating your first repository. And you'll be soon let's look at a few of the highlights to why people are so attracted to this version control system implementation, as well as what keeps them there and enjoying what could otherwise be a mundane task. First, Git is focused on content. The importance of this is that it's a level of precision deeper than a traditional version control system, which only looks at file level precision. Git can actually follow the move of source code from one file to another over a period of time. Second, Git's idea of the staging area means that you elect which files you want to participate in the next commit. Rather than accidentally committing something that you didn't intend to, you must explicitly ask for which things should participate in the next commit historical action. Third, the idea of Git being open is one that is supported by the core tool as well as the surrounding services. The idea is to let people make contributions, or I should say more precisely, offer contributions to projects. And control system, you'll find that many of those items are in modest or significant contrast to the version control systems that you've used in the past. Thanks again for listening to the benefits of Git.
So, level this video. Hi Tijja, what is version control? What is Git? Get going, get Git, keep wins, get. This whole video is available in Git website. But this next is just cheat sheet. The most common Git command, Git diagram, is the difference between merge and erase. You click the cheat sheet. So Git cheat sheet available. Start a new repo. Git edit. Prepare to commit. Git add file. Choose which parts of a file to stay. Git add -p. Delete file. Git rm file. Name. And unstage on file. Git save. Git reset. File name. Check what you added. Git status. Check the Git file to Git status. And message clone existing repo. Git clone URL. Git add untracked files and unstaged change. Git add space dot move file. Git move. Git mb. Mb is move old file to new file. To tell Git forget about a file without deleting. Git rm cache file name. Unstage everything. Git reset. Make commits. Make commits and open test editor. Write message. Git commit. Make a commit. Git commit -m message. Commit all unstaged changes. Git commit -am message. Switch branch. Git switch name or git checkout name. Delete a branch. Git switch -c space -c name branch name or git checkout -b branch name. List branch. Git branch. List branches by most recently commit to git branch hyphen sort equal hyphen commit trade commit d date. Delete a branch, git branch space hyphen d space branch name. Push delete a branch, git branch space hyphen capital D branch name. So this is a push delete of branch. So different stage unstage changes, difference all stage and unstage changes, git difference add and git difference just stage changes, git difference double hyphen stage. Git just unstage changes, git and git diff commits. So diff commit between a commit at and its parent. Git show commit diff one file since a commit, git diff commit file name, diff to commit, give git diff commit. So a summary of a diff, git diff commit star state and git show commit state. While refer a commit branch, a man, a tag v0.1, a give commit ID, this is a commit ID, a remote branch, origin of man, current commit had, 3 commits ago had, this is, or had, this is 3. Discard your changes, delete unstaged changes to one file, git store file name or git checkout file name. Delete all stage and unstaged changes to one file. Git store double hyphen stage double hyphen worktree file name. Git checkout add file name. Delete all stage and unstaged file. Git reset double hyphen hard. Delete untracked files. Git clean. These are git stage. This is the edit history. This is the code archaeology. Look at git log man, git log file, git log graph man, git log online. Combine diverse branch. This is a git switch banana, git previous man. So before A, B, C, this is a branch, this is a main branch, this is a banana branch. So git man, git merge banana. So this is a man before and after. After is a B C. This is a man. D E. This is a D E. This is banana. And D E is a loss. After merge the branch A B C and this is a main branch and D E the banana branch. This is a merge branch. Git merge banana. Git replace man. This replace man. Git merge banana. Man and banana is a merge branch. To combine a sequence merge, git switch main, git merge sequence banana, git commit before main and banana. Git ABC is main, DE is banana. So git merge squares banana. So git ABC and DE is a main squares of banana. DE you just add this man and DE is a banana. So, and bring a branch up to date with another branch. एक fast forward branch merge. Git shift man, git merge banana. Before A, B, C, D, E. C is a man and E is a banana. So git merge banana. Git merge A, B, C, D, E. E is a man and E is a banana and E merge is a man. So git merge banana. Banana E is a merge in a man. Copy one commit onto current branch. Get cherry hyphen p commit. Before पहले हमारे क्या है A B C is a main branch, D is a other branch. So git cherry pick commit, git d abc and d add a man and this d e. Store a pulled file, git checkout commit file, a git restore file name source commit. Add a remote, git remote add name UI. So this is the gypsies of Git. Configure Git, import 10 files of Git, and pull changes of Git, Git pull origin man, Git pull US, Git patch origin man. So this is just available in Git website. And these books are available in Git website. What is version, short version, history, what is Git command, summary, basic, Git repository, recording changes in Git repository, and summary, Git alias, summary, branch in itself, branch reversion summary, Git on the server, distributed Git, GitHub, Git tools, customized Git and other system, Git internals, environments, application of Gits, and Git commands. So download the PDF file, click to the there and download PDF git file. The tools, messenger tools, command line tools, GUI tools, and hosting tools. Command line tools are TUI. Command line tools is a TUI, simple terminal UI. TUI is a terminal UI for Git command. T base mode interface of Git. For Git Git U, ATUI, Git client inference of negative. This is a T word. Okay. Manage Git history, Git commit, hyphen, fixer, and Git merge, Git flow, repo, Git branch workflow, cell prompt integration, manage large file, diff tool, manage procs, collection of Git tools, and other. So this website is available in tools, command line, GUI. This is a command line tools, and this available in GUI tools. Or this is Windows, Mac, Linux, Android. Windows desktop. This is a Git branch, GitHub desktop, source tree. This is a tree, and this is available in a tree. This is smart gate tower. This is a smart gate. This is a tower. This is an ME gate. Sublime merge. This is a sublime merge. And for length, this is available in GUI. Git source gate, relay gate, pragmatic gate, Git Kraken CLI, Git Bridge, Git Row, Git Gitonic. This is available. Okay. This is a GUI class. This is a hosting. Hosting like Git, GitHub, GitLab, Reddit, Foresight, Codebar. This is a available in Tangled, Azure Repo, Radically, or Jijo. This is available in Git hosting. Friends, start uploading Git config help. This is available of setup of config. This is guides, getting and creating project, basic snapshotting, email, fly, branching and merging, branching. This is the branching, Git branch, and description. Which is available in description of Git branch. Check out, choose merge. This is a merge. name. This is a git merge one description. This is a merge topic master. This is a merge topic and master. It's a merge this branch. This is summary available in Git website. So please read the all step of the Git. After the install, Git window download. Window download is a Git is a 64 setup. Window ARM 64 setup and some drive decent available. But now what? Give the go download the GUI. Download the GUI. So click the download your plan. This is a step-by-step process of the GUI plan. Community. Next is a community mailing list. This is a community logs newsletter distribution to Git. So to install the Git, the window, click, click here to the window. So this latest version of the Git of the window. Only 2 months ago. Really, almost 2 months ago, 20 April 2026. Still latest version. So this icon is a Git. So install the Git. This is a install the Git.